Good day, grade 12 learners. We are back with another video, another scenario whereby we will be looking at the velocity time graph, position time graph, and the acceleration time graph. Here we have scenario number 2, which is projected mass. Like you have a person standing at the top of a building. That person throws something with an initial velocity. You see, that object will go upwards. It reaches its maximum height. It goes back to where it began. Here, it goes back to where it began and then falls straight to the ground. And let's look here. We have a boy throws. You see, I underlined the word throws. Once you see the word throws or projected or something like that, but in here in physics you'll get more words like throws, projected, and something like that. Just know that initial velocity is not zero. We are throwing something with an initial velocity, and we have a boy throws a stone upwards with a velocity of 5 meters per second from the same building. Okay, we have a boy here and at the top of a 70-meter building. This boy here throws a stone upwards with an initial velocity of 5. What do you think is going to happen to this stone? Of course, this stone here will go upwards until it reaches its maximum height here, where its final velocity will be 0. After that, it's going to return to where it started here. After that, it's going to fall to the ground. I don't know which speed or velocity, if you want to call that. Let's look at the velocity time graph, where you choose upwards as positive, represented by the red ink here. The red ink here represents where you choose upwards as positive. You choose upwards as positive, and your ball here is going upwards. That means it is experiencing what? A positive velocity. That's why it started here. As it goes upwards, it loses some of its velocity. Like here, it can be 5, 4, 3, 2, 1, 0, and it stops here. That's why here you see the velocity decreasing until it reaches its maximum height here at time x. This is where it reaches its maximum height, and we have it's gonna start after here it's gonna start gaining velocity, but in what? In negative direction, because you choose upwards as positive, but now it starts going downwards. That's why it starts to experiences a negative velocity. This time here, it represents the time it takes for the ball to sorry about that, I got called, but let's continue. I think I was explaining this right here, the -5, and your ball here will start from 0 going downwards. It will start from 0, -1, -2, until it reaches here -5 meters per second. Like, this is the time it takes for the ball, for the where do I keep saying ball, for the stone to return to its original position where it was thrown initially. After that, it's gonna fall down here with the speed increasing. We're gonna start from -5, -6, -7, -8 rated up until negative that number here where it stops. It will hit the ground and stop moving. And remember here, the displacement here is 0. Why is it 0? Okay, let's say your ball here, it moves to a distance of 10 meters. 10 meters, positive 10 meters upwards. And it comes to a maximum height here. After that, it starts to fall. It will fall another 10 meters to where it started, but here it will be a -10. Positive 10 plus -10, they will give you 0. That's why here the displacement is 0. Even if you have to calculate the time it takes for the stone to reach the ground, you will include the displacement from here to here, which is 70 meters. From here to here. I hope I'm clear. Okay, what about when you choose downwards as positive, represented by the blue line here? Okay, you choose upwards as positive. You choose downwards as positive. Also, initially your ball is going up. It experiences what? Negative velocity. That's why here it will start from -5, -4 up until 0, where it reaches its maximum height here. Your direction is downwards positive, but this ball here is going, you will excuse me, this stone here is going upwards with a negative velocity. Remember that velocity is a vector quantity. It can be both negative and positive, but speed is always positive. Like distance can never be negative, but displacement can be both negative and positive. I hope I'm clear. We have after this, the stone here will fall to a positive direction. That's why it experiences a positive velocity. Up until this time here, it hits the ground and stop. Remember that if you want to calculate the total distance traveled by the stone, the area under this line here, it will give you the displacement. You take this area and you plus this, you take this area and you add it with the area you find here. Like you find the area of here and you find the area of here. After that, you add them. It will give you the height from the ground up until here, where it reached its maximum height. And let's move on to position time graph of this thing here. And with the position time graph, you choose, like if they say sketch a position time graph, just choose upwards, or let me say if your projectile is going upwards, just choose downwards as positive, so that when sketching this, it will be easier for you, you see. But do what's best for you. You can either do it this way or do it the other way around. But let me explain here. Let me start with here. You choose upwards as positive. You choose upwards as positive. This is like where we take the ground here as our zero reference. Like we don't take the 70 meters as our reference point. Remember that a reference point is where we start. You see, we start doing something. Ne? That's our reference point. But here we take the ground, or we take where the boy is standing on there as our zero reference. You see, it will throw a stone upwards. It will reach its maximum height here at this point here. This is where it will reach its maximum height, and then obviously it will return to where it started here. This is the time it takes for the stone to return to where it was originally thrown upwards. And after that it will start experiencing negative displacement, because your choice of positive direction is upwards, but the displacement, the stone is going downwards. That's why here it experiences a negative displacement here. But if you choose the top of the building here as the reference point, like it doesn't really matter where you choose your reference point, your graphs will look the same. And here is the time it will take the ball to reach its maximum height, and here is the time it will take the ball here to return to where it was originally thrown. And of course it will eventually come down here. That's why your parabola here goes all the way up until the ball hits the ground here. Oh, I hope that was clear. And even if you choose downwards as positive, the same thing applies. This is the time it takes to reach the maximum height here. The ball will reach its maximum, the stone will reach its maximum height here, and after that it will return to where it was thrown. And because you choose downwards as your positive direction, the stone here will start experiencing the positive displacement. That's why you have your line extended to here. It will start experiencing positive displacement. And yeah, I think we are done with the position time graph. Someone might ask, what does the gradient of this position time graph tell us, or what does it show us? Like, you don't even need to worry about the gradient of this parabola here, because even if you it is not constant. The steep here, or the slope here, or the gradient here is not the same as gradient of here. You see, it changes within every point, unlike the straight line here. The gradient is always constant. You see, it does not change. It's always 9.8 or minus 9.8, like here. And that's it. Let's do the last one, the acceleration time graph. Of course, if you choose upwards as positive, and gravity acts downwards, what do you expect? You expect the gravitational acceleration to be minus 9.8. But if you choose downwards and your displacement is also downwards, this is where you will have a positive 9.8 meters per second squared. Like, it does not change. Let's move to the last scenario, and I think I will do that in the next video. So I will see you soon.